Welcome, this is School of Magic, where learning things together is magical. Entering question 21. You have a diagram that looks like this. Dotted line and 40 degrees. Two forces of magnitude 6 newtons and 8 newtons. 6 newtons and 8 newtons. I'm just going to randomly draw them here. Act at the point P. Both forces act away from point P and the angle between them is 40 degrees. Act away, so means this direction. Figure 21 shows two lines at an angle of 40 degrees to one another. On the figure, draw a vector diagram to determine the magnitude of the resultant of the two forces. So they want to draw a vector diagram. In this case, I'm going to teach you how to draw a vector scale diagram in order to find the resultant force. Okay, this is called the parallelogram rule. This is something that you will need to know as well. What does parallelogram rule means? You know what a parallelogram is. It's when you have two pairs of equal sides moving in the same direction. One pair moving this direction, another pair moving this direction. Similar to this. Okay. One of the members of a parallelogram, I think you're quite familiar, could be a square. In this case, a square is also parallel, both parts, the pairs. How are you going to draw this one? Easy. Remember what I said about vectors. This is just a general approach. When you actually draw a vector, you have to follow vector by vector. So if you have a start here, and let's say you have 8 newtons. In this case, you're represented by 8 centimeters. Then you draw in 6 newton or 6 centimeter. Make sure again, it is at 40 degrees. Then this will be your end. You know the resultant will be from start to end will be here. This will be the resultant force. But is this the only two paths from start to end? No, there is a third path. The completion of your parallelogram rule, which is instead of starting with 8 newtons, there's no rule that says you cannot start with 6 newtons. So if you start with 6 newtons, which is 6 centimeters, and then you connect your 8 newtons here, which is 8 centimeters, you still will reach the end. And that is why it's called a parallelogram rule. When you draw the vectors, the complete set of vectors, which is this and this, you end up having a parallelogram. Also, you also end up having the same result. Okay. When it comes to resultant forces or when it comes to vector diagrams, there's actually 3 paths. 2 paths that forms a parallelogram and resultant. So in this case, once you draw everything to scale, 6 cm, 8 cm, 8 cm, 6 cm, please measure what this is. So resultant F, the scale here will be 1 cm is to 1 newton. I give you a few minutes or a few seconds to actually get a ruler and measure that while I check the range for you. And you should have around 13 to 13.4 newtons. So your ruler should measure around 13 to 13.4 centimeters. Okay, still remember, there are a lot of techniques to solve a question. As I'm getting feedback from some of my students, as long as you use a valid physical equation to get an answer, and your answer is correct, then well done. There's no one way to do physics. There's a lot of different ways to do physics. If you can find more, well done. So I hope you enjoyed this video, and please provide me with some feedback.